Welcome my dear super engineers, and now we are going to learn about the set operations. So we have already studied about what the sets are and how they actually work and function by the following examples. Now we are on our operations of the set. So first thing first, what are the operations in the set theory? Well, just like in traditional mathematics and the simple calculation is there are addition, subtraction, multiplication, division, and these kind of things that do exist. But in the set theory, we are not going to work with the division and multiplication. Instead, we are going to work on something different. So to check out that, let's start with the intersection of set. So let me take you to the board. So here we are, and let's raise our curiosity genius. Here is our curious engineer, ready to learn something new. Okay. First of all, I would like to tell you that there is something which is very important to learn in the set theory itself, which is Venn diagram. V-E-N-N, Venn diagram. This was name on a mathematician. It is the logic in the set theory, and set theory is actually the mathematics of the logic. So here is our set. Let's name this set A, and here is our set B. So now we have two sets here. Let's, for a better understanding, let's say and this is our universe U. Okay, now let's define these things first. So our universe is natural number. It means 1, 2 up to infinity. Okay, 1, 2, 3, 4 up to infinity. The set A is actually the table of 2, which means 2, 4, 6, 8, 10, 12 and so on. Let's say that it is also infinity. Now let's define the set B. Set B is the table of 3. So 3, 6, 9, 12 and so on, and it also goes up to infinity. So these are the basic definitions that we have created to understand our set theory. Now let's see that what actually is happening inside of it. There is something, as you can see, there is something as common between A and B. Here it is. It is defined as A intersection B. So this opposite U symbol represents intersection or common area. Intersection. Intersection means common, like you can see the 6 is coming in both the places, the 12 is coming in both the places, and there are so many numbers that are common between the A and B set. And obviously there are the different numbers like 2 and 3 are not coming in each other. These portions are here like 2, 3, that way. Okay, so we have established the definition of this one. So A intersection B, this is what the intersection actually means. For just the simple English, you can call it as common between A and B, A set and B set. So we have completed our intersection. That's all that we need to learn about the intersection. Now let's see that what is the meaning of the union. Okay, so for better understanding, let's change the page here. Let's again make a Venn diagram. Venn diagram is this diagram that we need to make for the better understanding in so many problems that we used to do and calculate. Let's make our set A and the set B here, and this is our universe U. Let's call it set A, and this is our set B. Let's define our sets first. So the set A is again, let's say for the very same example, 2, 4, 6, 8, 10. or the even numbers, or you can also say it as the table of 2, and B is the table of 3, 6, 9, 12 and so on up to infinity. Universe U is natural number, which means 1, 2, 3, 4 up to infinity. So we have defined everything. Now let's see that what is the meaning of union. So let's mark it first. Here is the marking. So the marking that I just made actually representing the union. Union means totality of both the sets. So it includes every place. Let's write it down, that how it's gonna be written up. We are going to write it as A union B. So this symbol is representing union, as the opposite U was representing the intersection. This is our union. Union means totality of both sets. In the logic world, the logics of the Venn diagram are very important, and obviously there are significantly so many kind of the applications that we can use in day-to-day life to solve the problems using the Venn diagram and the set theory. And these are two important terms that we have just studied. That is why in discrete mathematics, which is one of the part of the mathematics taught in the computer science specifically, to make people understand how the computers can use this kind of the mathematics which is based upon the logic. So that's all about the union and intersection that we have just learned. Let's also see that how it will going to look like. Let's see it here. Like in the case of intersection, we are having A intersection B, which will gonna be 2, 3, 4, 6. Let's use the brackets. 2, 3, 4, 6, 8, 9, 10, 12 and so on. Is it true? No, it will be true if I change one simple thing. Well, that is the attentiveness that we require when we do the things. That's the tricks of the teacher. A union B. This is A union B. I just changed the page to make you a bit confused and actually make you remember that actually the totality of the both sets is called union. So what is intersection? Let me write that here. What is intersection? As in the form of example, let's see. Let me do this, and here is our intersection part. So for the intersection, what we can have is 6, 12, and can you guess the next number? It cannot be 14, it cannot be 16, it can be 18, because 18 is coming in both the numbers, right? Then 24. These kind of the numbers which is coming in both A and B. Both A and B is called intersection. They intersect. So now I think that you have got the idea of what is intersection and what is union. So we have completed our intersection and the union. So we have said these two, and we are going to study the next two in the next one. Till that time, take care, stay curious and be attentive. Hello my super engineers, and now we are going to see the remaining two set operations, which is difference and symmetric difference. So what is the actually difference between the symmetric difference and the difference? We are going to solve that up, don't worry, and let's start with the difference part first. Let's say that we are having two sets. First let's A and then let it B. I'm not using the Venn diagram for this because I feel like it's not important. So now the set A is having 1, 2, 3, 4, 5 and 6, these elements. And now let's say B is having 2, 3, 8, 10, 12 or let's say 11, these elements. Now let's see that what is the meaning of the difference here. So we are going to check the difference. So there can be two types of the differences here. The first one that we can have is A minus B. The second one that we can have is B minus A. B minus A. In both the cases we are finding and trying to find the difference, but it will going to give us the different results. I'm just writing the result, try to observe that, and then we are going to talk about what is the difference. So in A minus B, what we are having, what we left with is 1, 4, 5 and 6. And in B minus A, what we are left with is 8, 10 and 11. So as you have already noticed, there is something. First of all, there is no negative sign in the sets. We don't have any negative in the set theory. We only have the positive integers. Okay, like in this case, you can have this kind of the numbers, but on subtracting you are not going to get any negative number. Well, that's interesting, isn't it? What is the meaning of the difference then? Well, let me elaborate with this one. Let's check out the first one first, A minus B. You just have to eliminate the B's element from the A's element. So let's just cancel out this one. 2 gets cancelled and 3 gets cancelled. The remaining part are actually our difference from A and B. What is the difference? What is the remaining once you remove the elements of the B which is present in A? That is the logic here. So let me write that. Eliminate second element, second set's element from first set. I am not written it as A and B because this definition will going to work on both the places. Okay, so we have understood this thing. Now what can be B minus A? So for the B minus A, that is our second part of the question, what we are having is remove the elements of A which is present in B. So I'm using the red color, I'm trying to use the green color here. Okay, let's use the white color. I think that will be more clearer. No, it's not clear. Let's use the red color itself. So 2 gets cancelled out, 3 gets cancelled out, and what we are left is 8, 10 and 11. So here is our answer, 8, 10, 12. So the difference between B minus A is 8, 10, 12. This is what we meant with difference. This is the difference we were actually talking about. It's B minus A and A minus B. These are two different things, and we mean with eliminating the elements of one from the other and not actually subtracting anything. We are not actually subtracting anything. This is the meaning of the difference. I hope you got it, a very clear pointed explanation in that thing. Okay, I was talking like that. Okay, now we are on our symmetric difference. So let's